Hello, and happy Apollo Day to everyone. My name is Hesham Salman, and I'm going to be talking to you all today about how GitHub Mobile uses Apollo to move much, much faster. Specifically, what I'll be talking about is how GraphQL has been a game changer for mobile engineers and how it enables developer speed, how it reduces cognitive load and enables consistency, how it helps us build a better product, and how it makes clients happier. I'll be showcasing putting these concepts into practice by wiring up the basics on an iOS sample app. While I'll be using iOS for my demonstration, all of the concepts I touch on in the iOS demo are applicable to Android. After the demo, I'll come back and talk about some of the things we're currently exploring and experimenting with using Apollo. Before jumping in, let's talk about who I am. As I said earlier, my name is Hesham Salman, and I'm a native iOS and Android engineer. I'm also, as you can probably see, I'm a guitarist and a bassist. And in case anyone is wondering, I primarily play jazz and blues. I'm the first mobile engineer hired to work on GitHub Mobile, and I previously worked on its open source predecessor. GitHub Mobile is really a labor of love from everyone here at GitHub, and it started as a community-driven open source project called GitHawk. With all that said, let's just dive right into the talk. So GraphQL has completely changed the way that I approach networking. GraphQL has honestly changed everything about how I think and conceptualize networking. Moving from REST over to GraphQL has been as monumental a shift for me as moving from SOAP to REST. GraphQL takes a large and complex set of instructions and condenses them down into a smaller set of concepts. HTML gets are most analogous to GraphQL queries, while posts, puts, patches, and deletes are all condensed down into a GraphQL mutation. Subscriptions are most analogous to WebSockets and provide live updating data and information. GraphQL puts the power into the hands of the client. The client has everything available to it that is being publicly exposed by an API in the form of a schema. Whereas in the RESTful mindset, the results of a network request are determined by whatever the endpoint returns, GraphQL allows clients to specify exactly what they want. That means that no part of a response is wasted, which allows for less data consumption. The tooling provided by Apollo and the open source community makes for a fantastic developer experience by allowing developers to test drive their requests before including them in production. In my demonstration, I'll be showing how quickly and easily Apollo can generate native code, as well as one of my favorite tools, GraphQL. GraphQL enables developer speed. GraphQL code generation will change your life as a developer. It is the keyword when it comes to GraphQL, generated. By generating models and requests, we end up saving tons of hours that we would have otherwise spent writing boilerplate. Many developers, myself included, like the concept of a network model that serves as an intermediary between your client's UI models and the service JSON response. With GraphQL, those models are generated. And since models are generated, there's no more time spent parsing network responses into native models, either manually or through provided system frameworks. Even though encoding and decoding has gotten a lot easier over the years with iOS is codable and Kotlin's built-in serialization, it's still a consideration that needs to be made, and it's still time-consuming to implement. Apollo thankfully makes it even easier than it's become over recent years by automating the process for us. Preparing a network request is also quite simple. Since requests are all objects, they're able to declare their arguments, which allows for ease of use and ease of understanding. GraphQL reduces cognitive load. So this is something that I didn't really understand or realize until I spent a good long while using GraphQL. When making a REST call, there are just so many things to keep in mind. What endpoint am I hitting? Is the response going to be an array or is it a dictionary? What types do I cast this response to, and how do I even parse this thing? Did I spell my keys correctly? And are there any special content types or accept headers that I need to be worried about? GraphQL takes all these issues and all this baggage and it just abstracts all of it away. All the GraphQL requests head to the same endpoint, meaning you don't really have to worry about getting that address and its content types and accept headers just right. It also means that you're spending less time asking an API engineer how to use their new API. As I previously mentioned, the responses from GraphQL are typed, and what that means is that we can natively inspect on them and that our IDE's code completion should guide us as to what's available on them. The responses being fully formed objects with IDE support means that there's no confusion about how to handle it, assuming that Xcode and Android Studio are playing nice anyways. GraphQL enables consistency. I know that consistency is a bit of a loaded term, so let's break down what I mean by that. Using GraphQL means that every network request lives in a .graphql file, and that these files can be largely identical between platforms that are using GraphQL. Every new request starts by writing it down in a .graphql file, and all these requests are located within the same folder. GraphQL also encourages writing and reusing small components in the form of fragments. I'm not going to dive into fragments during my demonstration, but fragments are an extremely powerful aspect of using GraphQL. They're bite-sized and generally composable, so they allow us to take a set of properties and standardize them across a type or an interface. Reusing fragments allows us to quickly prop up new queries and new mutations. And since we can use many fragments on the same type, each fragment can serve as a small lens into the functionality that we're gleaning from our API. As I mentioned earlier, GraphQL allows us to condense all the types of requests that we do in REST across just a few concepts. Calling each type of request is also quite similar, so there aren't any special cases or special rules to using any one request type. GraphQL enables us to build more product. When writing a new feature, think about all the time that's spent on networking boilerplate. When developers don't have to worry about writing and maintaining their network models, their parsing, and more, it just frees up those developers to work on things that matter to the product. GraphQL supports field-level deprecation, so we can be certain that any updates to our backend models won't break our mobile clients. The hours that aren't being used to maintain and update the networking infrastructure are hours that are reinvested into the product. While I won't be showcasing this in my demonstration, GraphQL allows developers to set up skippable parts of a response contingent on some condition being met. That means that a single network request can power multiple screens or circumstances without ever overfetching data. By utilizing all the features of GraphQL, we really can do more with less. GraphQL enables happier clients, and so quite frankly, developers are happier when there's less work to do, especially if that work is boilerplate work. As an engineer, I'm also personally happier when my application doesn't contain unused properties and unused classes. And there's something special about knowing that these same principles apply to network requests and responses. Since no part of a network request goes to waste, data consumption of a GraphQL app tends to be lower than its RESTful counterpart, and that's something that users will appreciate and thank you for. With all of that having been said, let's dive right into a demo. So as I said earlier, I'll be demonstrating on an iOS application. I have a starter app here, and all that it does so far is allow me to sign in. So let's go ahead and showcase that. And let's grab my two-factor auth key. All right, so as we can see here, I have an empty list of followers. Now, this application is wired up to take in the new results from a request. So let's just quickly view what we have. Here, I have a shared networking client. The client is able to query and to mutate. Aside from the client, I have a concept of a follower list item. The follower list item is a simple Swift UI view that is representative of what I'll be showcasing. As you can see here, it has an avatar, a login, and a name. Its counterpart model also contains those properties. My list view is simply just a list of follower list items. It fetches the followers on appearance, and so everything is wired up to accept new followers. Let's take a look at our follower service that's being used in our list view. It has one property, which is the list of followers, and otherwise, that's it. We have this function here to fetch followers, but there's nothing quite there yet. So let's go ahead and start implementing this function. Now, I'll be using GitHub's open GraphQL API for this. Everything that I am seeing here in GraphQL is available publicly, so you are more than free to follow along and do this as well. So we know that we are looking for followers. I tend to start by using GraphQL to look for the object or property that I need. GraphQL is a tool that allows us to explore and inspect upon a GraphQL API and basically build any query or mutation that we might want to build and test it out before including it into our app. So, knowing that we need followers, let's start by just searching for followers. I can see here that followers lives on users. Let's start writing a query, and let's name it followers. In GitHub nomenclature, the current user is referred to as viewer. So let's just go ahead and grab the viewer's followers. Let's click into the followers query to find out more about it. We can see here that it takes 4 optional arguments: after, before, first, and last. These are primarily intended to be pagination arguments. I'm not going to support pagination in my sample application, but since I'm not going to support pagination, let's just go ahead and try to fetch a pretty good number of followers. So let's go ahead and fetch the first 100 followers. That seems like a pretty good round number. Let's look at what type the followers query returns. It returns a follower connection. A follower connection contains these 4 properties. The majority of these properties are also around pagination, which, again, we're not going to support, so let's ignore the majority of them for now. The only one that we're going to need is nodes, and as we can see in the documentation here, a node is a list, or the nodes are a list of users, or in this case, followers. If we check back on our model, we'll see that we need an avatar URL, a login, and a name. So using that information, let's dive into user and find the appropriate properties. So just by scrolling right there, we can see that a user has an avatar URL. So let's just go ahead and grab that. If we scroll down further, we'll see that a user also contains a login. So let's go ahead and grab that. GraphQL supports smart typing, and it supports auto-completion. So we can just go ahead and probably guess the name of what we're looking for, and it'll help us out a little bit. And so with this is actually our entire query. This is everything that we need to fetch a list of followers. So let's go ahead and run this just to double check that it looks okay. So as we can see here, I have a pretty good-sized list of followers, and they all seem to include the information that I asked for: the avatar URL, the login, and the name. let's go ahead and take this query and let's put it into our sample app. I'm going to create a new file here. And I'm just going to call it followers.graphql. I'm just going to paste what we have. Now that we have this file, we have to generate the native models for the response and the request before we can begin using it in Xcode. Let's go into the terminal and look around. I have a CodeGen folder. Inside this CodeGen folder, I have a Swift package that allows me to generate Swift native models for my GraphQL queries. So let's just go ahead and run that package. So what's happening now is that Apollo is basically looking at my directory that contains .graphql files and generating native models for those files. We can verify that it worked by checking out our status. We see a change in API.swift. So let's go ahead and just diff API.swift to double check what changed in there. We can see that I have a new query called followers query. Additionally, I have a struct for that query called data, which contains its data. We are now ready to start using this new query within our iOS application. So let's go to the follower service and get ready to use it. We'll start by using our shared networking client to trigger a query. We know that our query is called followers query, so let's just go ahead and use that. It takes no arguments, so this is all we need to trigger the followers query. When we look at the result, we know that it returns data. Xcode's autocomplete may or may not be helpful here, but let's cross our fingers and see what happens. Now, we know that basically this is going to return data in the same shape that we had here. So it's data, viewer, followers, nodes. So let's go ahead and just map that. Data, viewer, followers, nodes. Oh, and let's map it. And so we have nodes here. The nodes, I think, might contain optional values in case something just didn't serialize correctly. So let's go ahead and filter those out. And then let's go ahead and map those into our expected data type, which is follower. We know that a follower, as we defined it in the GraphQL query, has an avatar URL, a login, and a name. So let's go ahead and type that in. Here we can set the cache policy for our query. There are many cache policies to choose from, but for now let's just ignore the cache completely and just move on with fresh data from the server. Here we have our completion block for responding to a successful or unsuccessful attempt to get data from the API. So here we can switch on our results, and we can handle a case of success or failure. So in the case of success, I think all that we really want to do is set this object's list of followers to the followers that we just got from the network. In the case of failure, since this is a sample app, we're just going to print out the error and drop a to-do in there to handle this more gracefully. And now I I believe that this is just about everything that we need to get this working, unless I mess something up somewhere, but we'll see. So here's our sign-in page. Now I'm just going to go ahead and grab my two-factor auth token. And look at that. We have our set of followers right there, right where we expected them. They all have avatars, logins, and names. So that's pretty great. So let's circle back and let's review what we just did during this demo. We used GraphQL to inspect on and build our network request. Using Apollo's code generation, we were able to take our request and get native models out of it. We were then able to quickly write up a network request, see that it worked, and we did so all in real time. Both the finished and the starter code for this demonstration are available on my personal GitHub page at iron-ham. While this demo only scratched the surface of all the things that we could do with GraphQL, I hope it's showcased just how quickly a team of engineers can move using GraphQL and inspires you to dig a little deeper into it. So while the demo only showcased the basics, let's talk about some of the things that we're exploring at GitHub Mobile. We're currently considering what it might look like to have a shared source of truth for our networking between our iOS and Android clients. In my demonstration, I generated Swift code for my iOS demo app. But since networking constructs live in .graphql files, we can have a shared store of GraphQL files across the iOS and Android application. By doing so and versioning it as a package, we could generate both Swift and Kotlin for the iOS and Android apps. Having a shared source of truth between the two apps is pretty exciting, and it's something that I'll be exploring in the future. We're also exploring data consistency. Data consistency as a concept has always been difficult to implement, especially to implement well across basically all the apps that I've worked on in the past. And what I mean by data consistency, I mean keeping data in sync across different screens within the same instance of an app or within multiple instances of the same app. In the past, I've achieved this with Realm or SQLite storage and a series of watchers and listeners, but I think we can do this with Apollo. You may have noticed during my demonstration that I elected to always fetch new data from the server. However, Apollo has a network cache available that can be used to immediately fetch data from. We're currently exploring using the cache to achieve our data consistency goals by utilizing watchers over certain queries and in-memory optimistic updates to the cache. This is something that we're in the early stages of exploring, but we're quite happy with the results so far. It's currently available and in use on user profile views across the app on iOS, and will hopefully be rolling out across more parts of the app soon. On iOS, we've built some view scaffolding capabilities. Specifically, we built a class that can take in a GraphQL client, a view type, and a GraphQL response type. Using this pretty thin set of data, we're able to scaffold up an entire list view that supports pagination, interaction, and more. This is something that's in heavy use across the iOS application, and there are tons of examples across the app. An example is like the follower screen on the iOS app, and basically any simple list view on the iOS app utilizes this scaffolded class. Additionally, in the spirit of scripting and automating more of our workflow, we've integrated our Apollo commands with our project generation scripts so that any changes to our GraphQL are reflected within our app for any developer that pulls new changes. Before wrapping, I want to make sure that everyone knows that they can always reach me on Twitter to ask me anything about GraphQL, iOS development, GitHub Mobile, or just about anything else you'd like to talk about. My DMs are always open, and I'm reachable at _ironham. I'd like to take a moment to thank Apollo for inviting me to speak today on Apollo Day, as well as everyone watching. Happy Apollo Day to everyone, and thank you, and see you later.